Welcome to SpareGear24. In this video, we will walk you through the complete interpretation of an industrial engineering drawing covering dimensions, GD&T symbols, machining surface finishes, and datum references. Let's get started. Let's start with the front view. It contains three equally spaced through holes of diameter 6 mm located on a pitch circle of dia 50 mm. These holes are typically used for bolts and mounting screws. The outermost diameter of the flange is 75 mm with the tolerance of 0.5, allowing it to vary between 74.5 and 75.5. The circularity tolerance of 0.2 mm is applied to the same 75 mm surface. This ensures roundness of the part remains within 0.2 mm. The three holes are controlled with the positional tolerance of 0.12 mm relative to datum A and datum C. The datum A is the bottom surface of the flange, serving as a primary flat reference to control orientation and location of the hole. Datum C is defined by 60 mm dia central bore axis, acting as a secondary reference to control the radial location of the holes along the pitch circle. This ensures that the center of each hole lies within tolerance zone of 0.12 mm, providing precise alignment with mating components. Now moving to section view, which reveals the internal feature of the flange. At various faces, you will notice surface finish symbol, which includes a horizontal bar, which indicates the machining is required. The numerical values like 6.3, 12.5, and 1.6 denoting the maximum allowed surface roughness in micrometers. The face shows 6.3 micrometers requires a standard machine surface. The face has 1.6 micrometer roughness indicating a fine surface is required, often for sealing or fitting applications. The face shows 12.5 micrometer, which is relatively coarse finish, likely acceptable for non-critical surfaces. These values are compiled with ISO 1302 standard, guiding machinists how smooth or precise each surface must be after machining. Now moving to the GD&T symbols. The top machine face includes a parallelism tolerance of 0.05 mm relative to the datum A, ensuring it remains perfectly parallel to the bottom mounting face. The dia 60 mm counter bore is controlled by concentricity tolerance of 0.08 mm relative to datum B and defines a datum feature C, which is the central bore axis. This datum provides the radial and angular orientation for locating bolt holes and shaft. The central thread section is labeled M30 into 2.5, specifying a standard metric thread with a 30 mm major diameter and 2.5 mm pitch. The inner dia 15 mm hole includes a perpendicularity tolerance of 0.02 mm relatively to datum A, ensuring that hole axis is perpendicular to the base face. The 20 mm step is controlled by concentricity tolerance of 0.1 mm relative to datum B, ensuring that step is concentrically aligned. The dimension 40 mm has unilateral tolerance of minus 0.12 mm, meaning it can be shorter by up to 0.12 mm but not longer than 40 mm. The 20 mm shoulder is given plus 0.12 mm tolerance, allowing additional material. The bottom face of the flange, defined as datum A, has straightness tolerance of 0.02 mm, requiring the surface to lie within two parallel planes 0.02 mm apart, ensuring a flat and accurate mounting surface. That concludes our walkthrough of flange drawing. We covered essential aspects of geometric dimensioning and tolerancing, machining symbols, and the functional role of datum references in industrial design. If you found this explanation helpful, don't forget to like, share, and subscribe to SpareGear24 for more videos on GD&T, mechanical drawings, and 3D manufacturing.